All right. You guys can see my screen, right?
Yeah.
All right, nice. So it's been a while since our last talk on BIM, but let's just review that quickly. So we basically talk about the definition of BIM and also the features, especially BIM is object-based and also BIM is information rich. So we talk about that. We also talk about in terms of information, this is how we define ND BIM, from 3D, 4D, 5D, 60, 70. And you guys have already tried, BIM for design, cloud detection, which you just presented. And also, I think you guys are working on the 4D simulation project. And later on, we will also cover 5D. So that's how just the industry, how industry defines everything. Um, and then we talk about BIM is more than just a modeling approach. It's more of a management tool. It's more about a change to the existing process. And if you recall, we actually played a game, 2 weeks ago, to show that how difficult it is to exchange information among different parties in a project. Even inside the same company, the needs for information are so different. And the reason is our industry is very interesting. We don't have this so-called vertical integration, like from the beginning of design to the construction to the facility management. We don't have one company doing everything. So we have to bring different companies to the same project, forming what we call temporary organization, and then people will be dismissed. So it's very difficult for us to build a long-lasting relationship or establish the procedure for this kind of information exchange. And that's probably why most problems are rooted in this lack of communication, the lack of integration. And NIST actually reported more than $15 billion loss due to such lack of interoperability. So that's why the industry has been trying so hard to bring people together via contractual relationship. We start to see what we call the product delivery method change from the traditional design build method that separate everybody to the latest integrated product delivery or IPD. And BIM is the technical way of doing that. Like if we have this centralized cloud space that store all the information, and then it's possible for us to share the common vision. Okay, so this is something that I want to continue. Why this integration is really needed in the construction industry. First of all, you have to understand there are so many construction companies in the US. This is the latest data I can find. If you guys can find like a newer data, please don't hesitate to let me know. Please send me email. So in 2008, there were more than 770,000 construction companies in the US, but 91% of them only had 20 workers or less. Only 1% of construction companies in the United States had 100 workers or more. So the average number per company was only 9 people per firm. So you have to imagine, there's so many small-sized construction companies in the country. I really like the metaphor of boiling water to describe the construction industry. We have a lot of small bubbles, and these bubbles disappear very fast. So construction is a very risky business. According to BLS, Bureau of Labor Statistics, about 2/3 of the construction companies would run out of business after 6 years. So let's say if you start a company and say, hey, Professor Du, I really want to do this business. I started my own general contract company. Then after 6 years, there's more than 66% chance that you are not doing that business anymore. So it's kind of like a boiling water with a lot of small bubbles appearing and disappearing. Okay, so fundamentally speaking, we are lacking the ability to grow and to integrate efforts. So people tend to use the word fragmented to describe the AEC industry. We have these invisible walls between different disciplines and also different phases, from the owner to the architects to the engineers, to the builders, and finally to the users of the building. Sometimes the users are different than the owners of a project. And it's very difficult for us to share that information. And like I said earlier, construction organization, I mean, a project is considered as a temporary organization, or people call loosely coupled system. They are coupled because in order to finish a project, we have to bring different parties together, like designers, engineers, builders, but they're only loosely coupled, which means after 6 months, after a year, the project duration, they will basically move away. They will walk away and form this kind of new temporary organizations with other companies on a new project. So think about that. It's very difficult for you guys to make friends, to have this really good procedure. And also people, since we are working on our own interest, towards our own interest and our own focus, people tend to perceive information different way. For architects, they are considering the volume, the shape, the mass, the facade. But for structural engineers, when they see a project, they don't see the finish of the project. They only see the structural components of this project, the integrity of the projects, the load and the force of the projects. But if you talk about the same project with a general contractor, they even didn't consider the shape. They would only think about the money and time, and also the construction methods for that. And for the owner, they focus a lot on the functions. So people have these different needs. That means it's very difficult to bring people together in terms of sharing the same information. And you can see this from something called a work breakdown structure. Do you guys know, any of you know what is work breakdown structure? Anybody? Work breakdown structure, or WBS, is the way people, especially for general contractors, to decompose their work into smaller pieces, such as for estimating, you have this project, you decompose them into different divisions and then into different materials, so you can have this bottom-up way of having this estimate. So the thing is, for different parties, people tend to use different WBS structure. So for example, we have 3 main WBS structure, or work breakdown structure. One is called a unit format, one is called a master format, and one is called the by-step or logic oriented. So the master format, this is based on resource. This is resource oriented. It's the most popular one for estimating. So estimators prefer to use this master format to organize their estimate. Why? Because this is resource driven. So if you check in the eyes of estimator, they see a project as concrete, masonry, metal, wood, openings, and finishes. If you guys, let me just get this RS Means book quickly. Are you guys familiar with this RS Means book? Can you see my camera?
Yeah. Yes. I'm not familiar with it.
Okay. RS Means book is what the general contractors, especially estimators, how they come up with the estimate, the budget. And it's a standard they are following. So if you go to the table of content, you will see some digits showing different, what we call divisions. So for example, I don't know if you guys can see this, like 01, that's a architectural cost, like a design cost. And for 0, I don't know if I have a shorter version of for 03, you guys can see that's concrete, and you have concrete forming. So basically this book contains all the unit price based on the nation's average number, and they also have a multiplier for each city. And everybody, I have to say most construction company, they follow exactly the same structure of organizing their estimate. And the way they organize, this is the table of content, you see This one basically shows 01 is the general requirements, 02 is the existing conditions such as the surveys, demolition, and structure removing, snow control. 03 is concrete, 04 is masonry, 05 is metals, 06 is wood, plastics, and composites, 07 is thermal moisture protection, etc. So this is usually, this one is called a master format. So everybody follows the same standard. But when you go to a scheduler, usually they don't prefer to use master format. They prefer to use a different thing called a uni format, because this is system oriented. You know, like a project, they see the project as building the foundation first, and then the basement and the superstructure, and then the substructure, superstructure, and the enclosure and the roofing. So it's actually how we build up a building. So for different parties, they do see the same work in different ways. That is also one of the origins of the fragmentation in the AEC industry. And also, like I said earlier, you know, let me see, I can play this. Like I said earlier, for the same object, you know, different parties will also be interested in different information. For example, for a structural engineer, they probably prefer to see more information related to weight or location. But for the construction cost manager, they probably prefer to see more information related to cost and location, and the location. So since we don't have, before BIM, we don't have a effective method to incorporate all the information in a centralized place, then people start to rely on different systems. That's why in a big engineering company, you see structural engineers using one program to do something, and estimators using a different one, schedulers using a different one, because we don't have a centralized one that can meet the need of every single party. That is the, you know, the difficulty. And this is a survey by JB Knowledge. It's a consulting company, and they surveyed more than 2,000 people from the construction industry, asking them what computer programs you are using. For example, for accounting, you see people are using Timberline, you know, that is used to be called Timberline, but now called Sage. Viewpoints, QuickBooks, and SAP, you know, you can see it's actually so diverse. And also for the estimating, the quantity takeoff, you know, people are using on-screen takeoff, OST, Bluebeam, Sage, Heavy Beat, blah, 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 you know, ProEst. Once again, it's very diverse. Estimating, you know, as you can see from here, there's no dominating program that are used by the most company. You know, people tend to use different programs. Scheduling, you know, Microsoft Project is probably dominating, but we also have P6, and we have, you know, Viewpoint, Smartsheet. So think about that. People have different needs. People have different interests. So that's why people use different programs. That is what we call the interoperability problem. And for product management, same thing. Even though Procore is very popular, but it's only about 20% of the market share. So most of them are below, you know, the 2 digits. And it's very difficult to find one that is being used by most companies. So now imagine the difficulty of you working with another company. So think about the nature of a project is, aside temporary organization. So you have to form this temporary organization with a lot of new companies. So every time you have to ask, hey, for your project management, for your accounting, what program are you using? Then they very likely, they are telling you some name that you have never heard about. That is the reality in our industry. Not only you focus on different things, or you are interested in different information, but also the tools you are using are fairly different. And another thing is what we call the rebuying data and redesign problem in the AEC industry. As you can see, just imagine every time when you do something, you are generating some data. So for example, for the planning, you are definitely generating some data about this project. The design, yes, you are generating the data related to the architectural design, structural design, that's data. Construction, you're further generating the data such as the as-built condition, the job site condition, and finally, O&M, the operation and maintenance. But the thing is, none of these parties are willing to share their data with the followers. So once the owner finish their conceptual design or the plan or the program in the project, they basically just provide the minimum data with the designer, and significant data will be missing from designer when they turn in their data, their drawings to the general contractor. So most likely, the designers, the architects or engineers, they are using some kind of a BIM program to design the project, but most of them just print out the 2D drawings and send that paper-based 2D drawings to the general contractor, even though they have a much better model built in. And similarly, a lot of general contractors, they are hiring consulting company to rebuild a 3D model or BIM model based on the AutoCAD model. But finally, when they turn over this project to the user of the building, they only print all this user manual and this as-built drawings, and they don't want to share their model with the final user. And what is the reason? Can anybody give me a quick guess why people are doing this?
Propriety?
Or for what?
You said the private firms are not sharing it with the user.
Yeah, like everybody,
right?
Yeah, everybody on this on this chain, they just don't want to share the data they have, complete data they have to the followers. Why?
Propriety, but maybe that's not what it's about. Maybe it's something else that we're talking about.
Okay.
So can you ask the question again, please? And I'll give you a different response.
Yeah. So basically, you see here, like every party, they are working in this linear way, right? So
right.
when they finish their work, for example, like a designer, they are generating a lot of data, like really, really good 3D models. But when they turn this over to the general contractor, they only print out the 2D drawings instead of sending all the data they have to the general contractor. So I guess my question was why they are doing this. Why don't they just share all they have to others?
I think it's also to limit liability.
Yes.
Because a contractor can use the data and then do something else with it that it wasn't actually supposed to be used for. So just to limit liability.
Exactly. So I'm going to show you this one. Liability, a lot of people believe that's a technical concern. No, liability is actually the biggest concern. Liability is the obstacle of information sharing. If you check this one, is the claims by project type from 1995 to 2004, 10 year. You can see the frequency is really high, for house, like a residential projects. That's about 30%. So which means when you hire a builder to build a custom home for you, there's a 30% chance that you don't like each other, and there's some kind of claims. Like for let's say for office, for public projects, yeah, you would think, these are, representing bigger companies and bigger builders, but still you are expecting 5 to 6% chance of having some kind of claims. And this figure shows the claims frequency per 100 firms, and that also shows, the percentage from 1995 to 2004, and you can see we are talking about 15% to 20% claims, which means if you are running business in this design, engineering, or construction business, very likely you are facing 15 to 20 claims out of every 100 projects. So there's a really big chance of that. because of that, we want to hide our cards. We don't want to show off everything we have. So we only obey the minimum requirements, which written in the contract. And very likely in the contract, owners would only require the designers to share the 2D drawings. So that's why we see this big issue of data loss or rebuying data, because for general contractors, they are not happy with 2D drawings. They want to run clash detection, like what you guys did. What did they do? They hire consulting company. They outsource a lot of their BIM project to Indian company, and usually they charge them like say 100K for a model for a week or two worth of work. So it's really good business. It's a big money. And then, but the general contractor is still willing to pay for that. And we are wasting a lot of money. And we can see this from here. This is data I got from the Air Force. Air Force owns a lot of facility in the country. And every 3-4 years, they have to re-audit and resurvey their facility because of the lack of data shared by different parties, like shared by their own facility managers, shared by the designers or the general contractors. And the cost for resurveying or re-auditing their building is around $0.25 per square footage. And thinking about how many square footage Air Force owns, that's around 615 million square foot. So that represents about $153 million every 3-4 years just to buy data, even though some parties have the data already. That's ridiculous. Like Air Force paid a design company to design something, and after 3-4 years, they hire another facility management company to maintain the building. And there's no way for the facility management company to get 3D model from that design company. Then the facility management company will charge Air Force about $0.25 per square footage to rebuild the data. And that means every 3-4 years, we're wasting the taxpayers' money at a range of around $150 million. That's the problem we are facing altogether. So, I hope you guys now have a good sense about the issues we have in the industry and why building information modeling becomes a key hot word recently. It's not about the fancy 3D model you see on a computer screen that it can rotate. No, it's more about integration. It's more about we see the hope to solve the most fundamental problem: vertical integration, horizontal integration, different interests in data, information sharing issues, liability issues. We see the hope to solve those problems and totally transform the nature of the AEC industry. That's why BIM is important. Okay, so I hope you guys get a sense. And then talking about that, what is the number one step the industry took to do that technical wise? Like I mentioned, contractual wise or management wise, people are using these new product delivery methods to solve the problems we are seeing. But from technical perspective, we are using something related to BIM to solve the problem. So this is something called the industry foundation classes. So what is industry foundation class? I think I mentioned that just a little bit. And I ask you guys the question, ask you guys, what's this? Two different people, we could give them different names. Somebody called this a desk, somebody called this a table. Okay, we understand when I say this is desk or this table, you know what I'm referring to. But to computers, it's different, totally different. So even before the emergence of a BIM, building information modeling, people start to talk about, why don't we develop a common standard for everything we see inside a building, so we can program computers to do something for us if we give them the same name, the same meaning. This system is called Industry Foundation Classes, or IFC. So originally, Autodesk and 12 US companies, they formed this initiative in 1995. and they use the computer concept called C# classes to define every single thing inside a building that you can imagine a building, like ceiling, structural column, concrete, floor, carpet, everything. They also define their relationship, such as window is in the wall, ceiling is above the floor. So they define everything, and then they can program them in computer. So everybody start to understand. The computer can understand that. But the things are changing so fast in construction, in building, right? Because we keep adding new things like a new equipment, new mechanical components to the building. So that's why we start to see the evolution of this IFC version. You know, the first one is called IFC 1.0, announced in 1997, and nowadays we have this IFC 4.0. And the people are start to talk about the IFC 5.0. And if you want to see what are including IFC, you can just go to this website. Let's go to Building Smart, Standards, IFC. And this is 4.3 is the latest one. Go there and then go to content. You can basically see, you know, what objects we defined and also their relationship. And if you just go to any of them, let me just try to find something we're familiar with. So let me see. Okay, FC beam. You go there, basically defines what is a beam. Okay, so FC beam is a horizontal or nearly horizontal structural member that is capable of withholding load, primarily by resisting bending. And it talks about it belongs to IFC structure member, and that the relationship is, you know, IFC root is kind of like the root of the IFC structure, and it's a IFC object definition. It's object, it's product, it's called element, it's a build element, it's called a beam. And finally, you have, you know, all the attributes of that, such as this, you know, the span, the slope, the roll. So that's the characteristics of that beam that you can imagine of. And also it defines the relationship, and I give you the visuals of that as well. And also like, what do we mean by different directions of the beam? And then they also program them in different ways. So for example, this is XML, this is Express. Those are different ISO ways to show the information. So now imagine that you have a whole library of things. Like next time, if you don't know how to define a door, for example, you can just go there and you can find the most standard definition to that. And also the relationship, and also all the characteristics, all the attributes related to that. This is called IFC. It's the foundation of building information modeling. And that's why today, if you open Revit, you can always export your file as .ifc in addition to .rvt. If you go to Navisworks, you can export it as IFC. Last week, we had a guest speaker from Synchro. And if you open Synchro, try it yourself, you can actually export a Synchro file as .ifc. So IFC becomes the English for AEC industry. So even though people are speaking different languages, but most people can understand English. Same thing here. IFC is the English to the AEC industry. So I have a really interesting video. I want to play that quickly to you guys and see how that is helpful. Here we go. Can you guys hear the sound?
No.
No? Okay. Let me do that again. So share advanced. How about now?
처음 듣는 말인데요. 제가 아는 말을 할 수.
Can you guys hear the sound now?
Yes. Thank you.
말인데요. 제가 아는 말을 할 수 있겠어요?
Speak clearly. I can't understand.
Tower of Babel, one of the biggest construction projects ever undertaken, designed to reach the heavens. But the engineers couldn't finish the job. Halfway through, everybody working on the tower was stricken with the inability to understand what the other fellow was saying. They were all still talking, but they weren't communicating. That incident is supposed to have taken place in about 5000 BC, and we've been trying to understand one another ever since. But not too long ago, thanks to technology, there came along an amazing invention that actually made this problem worse. What is it? The desktop computer, of course. Everybody's got one of these things today, and we've all set about busily automating every task we can think of. On a project like this one, for example, the designers have automated their drawing production, and the structural engineers have automated their calculations for determining the size of members, and the HVAC people have automated their calculation for thermal performance. But they're still not really communicating. You see, we haven't improved the processes that connect these tasks together. And that's because the software packages that make this computer do its job are made by hundreds of different companies. And each software program has its own way of defining terms for the computer to understand. So they all talk to the computer, but they don't talk to each other, which means the people who use them can't do a very good job of talking to one another either, at least not with their data files and electronic drawings and documents. And why is that a problem? Well, on a big project like this office building, for example, our fractured information system, this one we're all using, results in information that's often incompatible, inconsistent, or redundant. You can imagine what something like that adds to the cost of something like this. When you come right down to it, we're all wasting a lot of time. For example, an architect does an initial design and passes it off to the structural and HVAC engineers. Now they all work in parallel, isolated, making changes as they see fit. When they get back together to try to integrate all of their decisions, well, the results are something of a mess. It takes iteration after iteration to finally get it right. But there's a move afoot to change all that, to make all of the software packages talk to each other, to make them all operate from a single shared building model that provides a common language for defining a building project, kind of a universal compatibility. It's being spearheaded by a company called Autodesk, in collaboration with industry partners such as AT&T, HOK Architects, Honeywell, Carrier, and Tishman Construction, to name a few.
The alliance was carefully put together. There are more than a dozen companies. We're all global players. And the important thing about the alliance is that it represents a cross-section of companies that deal across the cycle of the building industry. People who design, people who engineer buildings, people who build, manage, maintain, and then recycle buildings. We're all partners in this.
This is one of the most exciting things that I've seen happen in our industry in the 30 years that I've been in the industry. The design professionals, the manufacturers have come together and are putting in place an intelligent information system that is going to provide long-term benefits over the next decades.
The challenge is pulling the alliance together first, and I think we've done a pretty good job of that. Creating the industry library, beginning to create that, and at the same time working on the concept of an open, totally open standard, if you will, that's global.
The biggest advantage that I see of this alliance over a longer period of time really is speed in construction. Speed in construction results in lower expenditures for owners, users, and also an opportunity for an industry to work together where it has not tied that well together in the past.
We will now, with the interoperability solutions with the foundation classes, be able to look at objects in a drawing. The drawing will become the beginning of a database, if you will, of objects. Those objects relate to doors, windows, walls, those types of things that you see in a drawing. However, these objects will be interoperable. Once the definition is set, other industries, or other disciplines, I should say, will be able to use those objects.
Standard objects that can be interlinked across the various disciplines in the construction industry is a tremendous advantage for customers. I think probably the value added to my customers and everybody's customers are essentially reduction in building the structure and some cost advantages in what it costs. And I think perhaps even the more important value to a customer is what I call life cycle costs.
The idea is to have industry-wide definitions for every object we use to design, construct, and maintain buildings, and then to create industry-standard definitions for the relationships between these objects. So when I create a door with my design software, your facilities management software automatically recognizes that it is a door. Plus, that door will have accumulated all the information defined about it as it was worked on by architects, engineers, specifiers, estimators, and builders. A truly intelligent business model. The data loss and confusion you've come to expect from translations and interpretations, that's all gone. What we're really talking about is interoperability, making things work together no matter who creates them, no matter who's involved. Now, if the success of this interoperability depends on agreement about terms and relationships, well, then it seems that getting the definitions right is critical. So who's going to create them? You are. Autodesk is working with its industrial partners to develop these definitions with the people who actually work in the architecture, engineering, and construction industries. The definitions will result from analysis done with today's top companies, large and small. And since no one company will own the definitions, any software company can use them to develop their products, which means you get freedom to choose. You see, that's what interoperability really means to you. It's all the benefits of integration, but with the liberty to handpick any application from any vendor you want. The definitions will be called Industry Foundation Classes, a terminology which may not mean much to you unless you're a computer programmer, but it's going to change the way you work.
Okay, guys, I'm stopping here, and if you're interested, I shared a PowerPoint on the UF campus, and you can go to the link, and there are 2 episodes for this documentary, very interesting documentary. So, quick question for everybody. Does FC mean building information modeling? Are they the same thing? Anybody from the class? Nobody?
I think BIM uses IFC as a kind of like a format, like an extension for objects and stuff. So, but it's not the same. Like BIM uses IFC.
BIM uses FC, that's correct. And FC is more the data structure for BIM. So yes, it's an extension format, but also it's the soul of building information modeling. You know, like how we organize all the objects. Since we talk about BIM is object-based. So what are the objects? How we define them? How we define the relationship with them? That's the logic is called FC. And of course, the extension is called FC. Yes, that's correct. And so the point that I want to highlight here is FC and the BIM didn't happen at the same time. They just naturally come together. So even in the time of AutoCAD, not object-based, not BIM, people have started talking about industry standard. You know, because we start to see the problem of the lack of interoperability or using the same language for different computer programs. So I have to say, IFC, the concept of IFC or the need for IFC probably came before building information modeling. But it just, you know, building information modeling soon became the natural platform to realize IFC. Then we just quickly turn IFC into some usable and valuable solution to a lot of problems. So I have to say, they are different. Or you can imagine BIM is more kind of like a computer, and IFC is more kind of like the operation system. So the OS of this, what we see today, actually comes first, and then the computer, and then there's naturally come together. That's the story of that. We will be talking more details of FFC and especially how that means to the programming part of that. But before that, let's talk about the application of BIM. Let me skip that part of that, here. So industry has an obvious trend towards the use of BIM. This is a widely cited data study done by McGraw-Hill Construction. So basically, in 2007, only 28% of the AEC company in the US were using BIM, but that number just boost to 71% after 5 years. So think about that, during that 5-year period from 2007 to 2012, about almost 50%, 43% of companies, half of the industry started to use BIM. You would be surprised that a lot of contractors actually uses BIM for more than 60% of their products, not just the architects, not just the engineers. If you check the data here, actually BIM is more popular for general contractors than the structural engineers. I don't know why, but looks like general contractors start to discover a lot of benefits using BIM, such as the class detection you guys just have done. And if you check this technology diffusion curve, it shows that for the early adopters, like how many people would adopt technology as early adopters and how many people are followers. 71% in 2012 is already here. Okay, so now it's 2020. It's been 8 years. I guess we are here already. So next time, if you go to a job fair and if you hear some companies say, hey, we are very interested in BIM, we're hiring somebody to start using BIM, they are really, really, really late. Okay, then you have to double think about their offer. And this study also surveyed more than 400 projects, total value more than $559 million. They started to see the benefits of BIM. So for the projects use only 2D drawings, the change order is about 18% of the contract value. Okay, so if the projects were using 3D standalone BIM, like I'm using Revit, you are using Revit, but we are not exchanging data anyhow, then the change order just reduced from 18% to about 11%. But if we are using some kind of collaborative BIM, such as cloud BIM or the assemble system that we'll be learning soon, then the change order number just reduced to 2.7% only. Change order is something we cannot avoid or hardly avoid in a project. But if we can reduce that, that means a big money saver, that we can save the efforts and the money for different parties. So talking about the BIM adoption in different regions, US, North America is really taking the lead. This is also all data in 2013. At that time, we start to see some company already used the BIM for around 6 to 10 years. 8% of the companies already used the BIM for more than 11 years. The majority of the companies actually used the BIM for more than 3 years. So US is really taking the lead in terms of BIM adoption. Okay, so we talk about the general concept of BIM and why we are needing BIM. So how BIM can be used to benefit a project. Did you guys see this graph before? This one shows the life cycle of a product. If not, you really want to, memorize this one. You are working in this area. You're going to start a career in this area. You have to know a project is more than just design. A project is more than just construction. Actually, we have planning phase, design phase, contracting phase, construction phase, closeout phase, and the operation and the maintenance phase. Planning happens more for the owner. For example, they need to do programming. It's kind of like, hey, I want to build additional office building for my company, and I start this program. And then you start to do some feasibility study, such as financial feasibility and a construction feasibility. And then you would hire a company, a design company, to do some conceptual design. The conceptual design only cares about the general size, the space needs, nothing related to material, nothing related to the final design, but it's more concepts of that. So that's called planning, okay? So after the planning, you have a signed agreement inside. It's kind of like the CEO from the company will approve your plan. Now, you as the owner will look for a designer, like an architect company. So you basically will have this request for qualification, request for proposal, RFQ or RFP, and you will select a design company, and they will do this something called a schematic design, something about the volume, shape, how many levels you want for your office building, and they will do the design development. You know, the maturity level is probably 50% of the final design, and finally 100% complete design is called a construction documents or CD. So once that part is done, you will announce, hey, I'm going to have this new project and I'm going to call for bid. Okay, so invitation for bid, invitation to bid. Okay, and then you will announce this project. A lot of times you will pre-qualify the bidders. So for example, you have to have 5-year experience in similar projects to be able to submit your bid. And then you will solidate the bidding documents, you will solidate the bids. And now let's jump to the general contractor. So now see this announcement, you want to bid for this project, you prepare the bids. How long do you have, usually, how long do you have to prepare a bidding document? Anybody? Nobody? I said that before.
Maybe about a month?
Yes, usually you have about 4 weeks to prepare bids, no matter how complex the project is. So I have to say, estimators, I hate to use the word pathetic, but they are the group of people that you always see working overtime. But when there's no new projects to bid for, you see these people are totally relaxed. But when they are working on some new projects, they have to work overtime. You know, I was working in Zachary. I was receiving phone calls from my friends, from my colleagues at 10 p.m. in the night, asking me some questions, and they were in office still doing the bidding document. Okay, so once you finish the bidding document, cost and schedule, you have to submit your bidding document before the deadline, okay? And then for the bid open day, you go to a place with all the competitors, all the other general contractors. And so basically me as the owner will get your bid, I will read out. So this is a document, this is the number I received from this ABC construction company, $1.2 million. And this is the number I received from this Thompson company for $1.3 million. So everything must be open and transparent. And most likely the owner will pick the lowest bidder. So this process is called the bidding process. And finally, they award a contract with you, sign a contract. And now it's the construction phase. You know, you have to do the procurement. Procurement means, oh, we probably have some long lead materials that will take really long to be shipped to the project site. So let me place the order now, the PO purchase order now. And they have this pre-construction. You need to assemble the team. You need to find the project manager, the foreman, general foreman, superintendents. You have the team, everything. And then you do the mobilization. Okay, so you go to the job site to mobilize your project. And also logistics, you know, like you have to have the temporary utilities set up, temporary water, temporary power. And then finally you can do your construction. So before the actual construction operations, you still have a whole lot of work to do. And also you have the product controls. So basically you have this earned value chart showing what you're supposed to earn, what you're supposed to finish on a given day, and what you have actually done and what you have actually spent. So you know, oh, we are doing good here, we are not doing good there. So you have to correct all the deviations. You have to make sure the project will be delivered on time, under budget or on budget. So that's called the project controls. So when that is done, we are moving to the close out. Okay. So one thing is called a punch list. What is a punch list? Anybody? What is the meaning of punch list? Nobody? Okay. So basically, I'm substantially done. So I invite the owners to do a walkthrough, and the owner will basically pinpoint, hey, I think you have to caulk the window frame. Oh, there's a touch up with the pen. So you document everything. That document is called a punch list, and it's the minor items you have to correct before the owners pay you the final invoice. Okay, that's called a punch list. We have a substantial complete. Substantial complete means I can move in. The function is good, but the job is not literally finished. I still have minor items to finish. Okay, and then we'll do final inspection. And after the final inspection is accepted, the owner will issue will issue the certificate of occupancy, which means people can move in, and we will do the commissioning. Commissioning is not the inspection. Commissioning is more kind of like a turn on, turn off the switch to see if the lights are on, the AC if they are functioning. So it's more the system of the building if this function. And finally, we do the final documentation and the final completion of payment. What do we mean by the final payment? Anybody? Why we have such a thing called a final payment?
Because there's quantity adjustments, and like they put together like you owe me this, but so they do like a final balance to see how much money you owe me because of things that weren't paid before and stuff.
Yeah, so that's the final. Yeah, that's the meaning of final payment. But why we have such a thing called final? Let's say construction projects are paid and billed on a monthly basis. So usually the general contractors would bill the owner, let's say, towards the end of a month, and the owner will have, let's say, a week or two to assess the bill received. The owner would likely hire somebody to inspect the job done and pay, the general contractor. So if the owner is already paying the general contractor on a monthly basis, when the job is done, why we still have such a thing called a final payment? This is because something called a retainage. Have you guys heard about a retainage? So every time when the owner receives a bill from the general contractor, they only pay 90%, most likely, most cases. And they basically save 10% of the payable in their own pocket. So by the end of the project, you will have 10% of the total value, not just the last month, okay? The total project value in your pocket. That is how you can hold your general contractor. You don't want a general contractor to walk away with all the unfinished punch list items. So you hold 10% every time. And unless you issue the final documentation, which means I'm totally okay, I stand off the product, you don't pay that 10%. Some companies, some owner even have this 1 year warranty period. That's called a workmanship warranty period. And you as the general contractor have to wait for a whole year to receive that 10%. Make sense? Okay. And finally, the job is done. We turn the job to the owner will turn the job to the user. So sometimes the owners are the users, like I mentioned the case, I'm building this office complex for my own company. I'm the owner, I'm the user, but it can be you're building a shopping mall and you're renting them out. So you're also giving this to the final users, or if you are customer home builder and you build a thing and you sell them to the homeowners. So we are giving them to the actual final users. So you have to deliver the OM data, the operation and maintenance data. You have to do the training, and also issue this warranty. So quick question: how where BIM can be used to benefit this product lifecycle? Anybody?
Estimate the time and cost.
So I estimate, which is contracting, right? What else? Can it be used for O&M, operation and maintenance? I guess the answer is yes, right? Can it be used for punch list? So actually there's a very interesting startup company that combined augmented reality, building information modeling to enable a much effective punch list process, right? Can it be used to optimize the logistics, such as the job site layout or how to move the different materials on job site? I guess yes, right? Product control, I guess yes. Design, I guess yes. Programming, people are using SketchUp to have this initial conceptual design all the time. So pretty much BIM can be used everywhere and anytime, okay? So from the programming, to the conceptual design, to the detailed design, we are using Revit. Conceptual design, people are using SketchUp all the time. Analysis, we use the robot structural analysis, the finite element analysis to generate the documentation, construction documents for the building to fabrication. So like we issue the shop drawing models, we send them to computer so the computer can prepare, the components, especially the structural, the steel structures automatically. And of course, general contractors can use BIM to perform the clash detection and also 4D simulation and 5D estimating. Construction logistics, like you guys see the synchro, one thing they can simulate the crane, tower crane moving, traffic. They can simulate how buildings building up, so that you have a better sense of how you should lay out your storage, staging area, and how you should coordinate the efforts. Operations and maintenance, we can integrate, the equipment information, the supplier information. We can integrate the lead information into that. Even for renovation and the demolition, people are talking about the use of BIM for them. So BIM actually is very promising to facilitate all the processes phases in the construction, in the AEC process. Okay, so with that side, what is the most important one we should know? Let me open this one. It's actually something called a pre-construction. So let me try to just finish the first part of this pre-construction service. What is pre-construction? Can anybody tell me if you know what a pre-construction service is? Can you tell me what that is? Nobody?
Planning and design.
Planning, design. Killing, you want to say something?
I think Abram was gonna say something.
So you agree, right?
Oh, what did he say?
He said planning and design.
Oh, okay. Yeah.
Okay, pre-construction is like, yes, it's about planning, but not about design. So pre-construction is after the design, but before the construction.
So
what that is? So what's that?
Is it also geotech work?
It can be about geotech work, but this is more about serving the construction operations, such as the collage detection. So you often run collage detection before the actual construction, but this is after design. So we call this pre-construction service. 4D simulation, synchro, that's also called a pre-construction. Of course, if you want to evaluate the job site condition, if you want to evaluate like the geotechnical condition, before you do the first shovel of dirt, that is called a pre-construction service. Why that is important? Let me ask you guys this question. When is the first time a plan is assembled? Digitally or physically? Of course, digitally, right? So you see that models all the time that people design different airplanes, and they also run simulation to see how the wings and engines can come together and how they should move them in the factory to put them together. So when is the first time a plane is assembled? Definitely digitally in a virtual environment. When is the first time a car is assembled? Of course, digitally in a virtual environment. But when is the first time a building is assembled? Most time in the field. So people do have the mentality from the East industry. People do have the mentality, let's get our hands dirty. We have this design, perfect. Let's do it. Let's do the job. Let's stop talking. That's the mentality that the most construction guys have. Unfortunately, that is not the best practice. Why don't we do the assembly of this building virtually, such as playing the video game, such as doing the synchro simulation, and let's see, oh, I'm going to do the earth moving there. Now, meantime, I'm going to move some concrete here. No, that's not working. Okay, let's change the plan. Now let's see if I'm doing this heavy lifting with this tower crane. Oh, unfortunately, there's somebody doing the curtain wall there. No, it's not working. Why don't we do that digitally first before moving to the job site? That is why pre-construction service is important. So you can imagine pre-construction service is more to assemble a building virtually, digitally in this virtual space to understand the process to resolve all the potential issues before you do the earth moving. That is called a pre-construction. That's why it's important. Pre-construction or pre-con, people use the word pre-con, are used in planning a construction project before the actual construction begins. It is critical to a project success. The pre-con phase is a summation of the planning services rendered before a project begins, such as including estimating, scheduling, risk assessment, for example, the unknown set condition, potential traffic, shortage of supply, shortage of laborers, potential hazards, and also maybe the heat of a pandemic, okay? Value engineering. What is value engineering? Anybody?
The cost?
Yes, value engineering means, can we change to a cheaper material? Can we change to a cheaper construction methods without affecting the scope or the function of a project? It is a term and a method invented in the World War II when US participated in the European wars. There was a significant shortage of materials in the US. So two mechanical engineers, I forgot their name, they developed this kind of concept called value engineering. So they received this design from the design company. Usually design company will give you the most robust, the best quality design. But these two mechanical engineers do see a lot of potential waste. Yeah, you ask us to use this potential PSI steel, but it's overkilling. Why don't we try a different approach without affecting the safety, the integrity, the scope, and the function? And that process is called value engineering. And today we're also doing a lot of value engineering. Quick question, guys. I'm the general contractor. I received the documents, construction documents from you, designed by some design company. And but based on my experience, I do think this pillar is not necessary. Can I propose a change to the owner? Yes or no?
Yes.
Yes. So when you submit the bid, you submit the appendix. It's a form. I forgot the name. It's an A something form, showing that based on my experience and based on my calculation, I think, when you build it, an alternative is to remove this many pillars, is to use a weaker concrete, this and that. That would save 15% of cost. Do you agree or not? If the owner believes disagree, then the cost submitted by this general contractor would be lower. Make sense? Because you are not only proposing a number, but also proposing a new solution which represents a lower cost. So I would consider that is your bid. So that's value engineering. It's actually very popular to a lot of general contractors. And of course, constructability review. What is constructability review? You guys have just done that, the clash detection. So that's all called pre-construction. All right, so I think you guys see this picture from the last week presentation. You know, this is a typical thing of a pre-construction. You have this like a post-it on the wall showing different, you know, milestones and also different major activities. You have this one shows the cash flow or labor force. You know, this is a P6 schedule, you know, showing the bar charts, job site layout, and more coordination post-it. Also, you have this computer generalized simulation. So you just sit down with different trades, with different subcontractors. You are doing this brainstorming and manned exercise virtually, digitally, before you actually do the hands-on work. This is called pre-construction, and it's becoming more and more popular today. So let's change the mentality. We are, of course, you know, we are definitely handy, you know, we are doing a lot of dirty hands work. That's a really good attitude, but let's do them in a smarter way, which is pre-construction. So next week, we are going to keep talking about what BIM can be used to benefit pre-construction. All right. So with that said, that concludes our class today. Any question, comments? If no, see you guys next week.
Do we have an assignment due next week?
I don't think so.
Professor?
Yeah.
We have an assignment due next week, right?
Do we?
The 4D BIM.
Yeah, the BIM.
4D.
The 4D BIM. If that is shows on the syllabus, then yes. Let me see. 4D BIM model still. Okay, I got that. So the 4D BIM presentation will be due in week 11. How about this, guys? Let's move this model due also to week 11. So that will give you guys additional 2 more weeks to work on that. Is that okay?
That's good. Thank you.
Yeah. And Professor, we should be using our own models, or you will be providing?
Yes, I think we had that talk. You know, originally I gave you a model, but it's boring. Like everybody presenting the same model. So we talked about it last week. Like you guys can use your dream house model, you know, or your beam trees model. And since you are working on team of 2, so you have to fight the other guy and to pick a model you like. Sounds good?
Yep.
Okay.
Thank you.
All right. So let's postpone the. Sorry, what's that?
Thank you.
Okay. All right. Yeah, let's postpone the submission of 4D BIM to week 11, and see you guys next week.
Thank you.
Bye bye.
Thank you.
Thank you.